Lucie. So for the Hudson Data GM project, I chose to study Lyme disease and its prevalence in the Northeast. I saw a correlation between precipitation, acorns, mice, ticks, and Lyme disease cases. Well, there is a clear relationship between mice that gave Lyme disease cases to ticks, the life cycle of ticks, and prevalence of Lyme disease in the Northeast. From there, it's not a big step to imagine that there also may be a relationship between precipitation, acorns, food for mice, and the number of mice. So I looked at a level 3 data set called Lyme disease and its prevalence in the Northeast. I then connected it back to a level 1 data set called Lyme disease connections. And I connected both those data sets back to a data set on precipitation, where the data was collected and compiled by NOAA, the National Oceanic and Atmospheric Administration. I also focused on New York during this project, because when I compiled the level 1 data set, Lyme disease connections, which provided data for Dutchess County, New York, and the level 3 data set, Lyme disease and its prevalence in the Northeast, which provided data for states in the Northeast, the only place I had in common was New York. While looking at the graph, I kept in mind that precipitation will lead to more Lyme disease cases the following year. Therefore, I saw a lot of correlation. I see a decrease in precipitation from 2014 to 2015. And then, from 2015 to 2016, I see a decrease in Lyme disease cases. My next step was to compare the data in New York from 2000 to 2007 for precipitation and the average acorn density. While looking at the data between precipitation and the average acorn density, I kept in mind that an increase in precipitation leads to an increase in acorn density the following year. However, I noticed fairly quickly that there was close to no correlation. I was very fortunate to be able to meet with Dr. Osbout, a researcher at the Carey Institute who works on collecting and compiling data for the level 1 dataset. So, I asked Dr. Osbout why there was no correlation. He answered that an increase or decrease in acorns depends on precipitation, but also on where it's growing, how much sunlight the acorns are getting, how many animals are eating the acorns, if plant diseases are common at the time, etc. So precipitation only has a weak correlation with acorn density. I then compared my data between average acorn density and average mouse population density. Since they both came from the same level 1 dataset, I was able to graph the years 1943 to 2007 in Dutchess County, New York. While looking at the graph, I kept in mind that more acorns lead to more mice the following year because it takes some time to have an increase in the population. Therefore, you can see for yourself that there is a lot of correlation. Next, I compared my data between the average mouse population density to the average nymph tick population during peak density. Since they both came from the same level 1 dataset, I was able to graph the years 1943 to 2007 in Dutchess County, New York. While looking at my graph, I kept in mind that more mice lead to more nymph ticks the following year because nymph ticks like sucking mice's blood. Overall, I saw that other than a few points, the average mouse population density and the average nymph tick population density are correlated. Finally, I compared the data between the average nymph tick population during peak density to the Lyme disease cases. Since they didn't come from the same dataset, I was only able to look at New York during the years 2000 to 2007. After talking to Dr. Osbout, I understood that more nymph ticks led to more Lyme disease cases the same year. By keeping this in mind, I was able to see some correlation. To represent all the data I've shown you so far, I decided to make a Rube Goldberg project for the years 2000 to 2007 in New York. I made one Rube Goldberg project for each year, so I had 8 in total. My Rube Goldberg machines show that precipitation leads to acorns, which leads to white-footed mice, which leads to nymph ticks, which leads to Lyme disease cases. I decided to show you 2 of the 8 Rube Goldberg projects. One from the first year of the compiled data, the year 2000, and the second from the last year of the compiled data, the year 2007. Year 2007 is the same chain of events as year 2000, but with different numbers, based on the graphs I previously showed you, and a different track to make it more visually entertaining. Through this project, I was able to learn about Lyme disease and the life cycle of ticks in detail. I am so grateful to have been able to interview Dr. Osbout and to have had such a supportive teacher. Thank you and goodbye!